so now we're looking at day 2, which is histograms and descriptions. You may know how to do histograms in the calculator. If not, I have a resource for you to go to learn how to do that. So on this example problem, it says this table represents data on the percent of residents from each state who are born outside of the U.S. Create a histogram to the right of the table. So histograms, sometimes the tables are set up this way where the bins or the group that we're going to use is already created for us. Sometimes the histogram is not. So I'm going to go through this example and then I'll kind of discuss a little bit more about histograms afterwards. So we're given this class. So 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, so on and so forth. And then it gives us the number of states. This class is giving us the percentage. It's the percentage of residents that are born outside of the U.S. Why they have it listed as class is because that's just their way of saying this is the group of percentages we're going to look at and how many states fall within that percentage grouping. So 0 to up to 5%, 20 states fall within that grouping. We don't know how many states within that grouping are at 0% or 1% or 2% or 3% or 4% or any decimal in between, but we know from 0 up until 4%, there's 20 states that fall within that percentage grouping. So what I've done is I've created a graph here. I'm going by fives because I'm going to be graphing this based upon the class or the percentages here. And then this is the frequency or the number of states that fall within each of these bins or each of these classes or each of these groups, however you wish to explain it. You might want to pause the video if you don't have this copy down yet because we're going to start graphing this next. So from 0 up until 5%, there's 20 states that fall within that category. So it's kind of like, in a way, we are drawing in 20 dots here. So for some of you, this might be a nice visual. We basically have 20 pieces of information stacked up on top of one another, and what that is doing is then creating the bar for us. Oops, I did not make that very even. Let's try again. All right, so that's our first bar. You don't need the dots here, but for some of you, that might be a visual that you like. Next, we have 13 from 5 to 10. With histograms, you want your bars to be as even as possible, so approximately the same size. So it's important to make sure that you're drawing a roughly accurate graph here with your tick marks, so that way there, when you begin to draw the histogram, your bars are approximately the same width. From 10 to 15, we're at 9. 15 to 20, we're at 5. 20 to 25, we're at 2. And then 1. So you can see it's pretty close to the line, so you might have a slightly different scale to make the bars over on this side a little bit easier to graph, but this is what our bar graph would look like, or our histogram would look like. With histograms, if the bins or the groups are not already created for you like they were here, then you want to make sure that you're looking at your data values and breaking them up into groupings that would make them approximately the same width that would get you through the whole thing. So what I mean by that is we wouldn't have wanted to do groupings of 3 here because we would have never, well actually 3 we would have, but say 4, we wouldn't have made it to 30 nicely. We would have had a bin that wouldn't have quite made it all the way. So you just want to create a bin that more evenly distributes the data so you can get a better idea of what your histogram and the shape of your distribution is looking like. When you go through and learn how to do it on the calculator sometimes will give you an idea of what a good bin width is to look at how far apart each of these increments should be, but you don't have to use that, and you can adjust it and modify it. Sometimes the calculator will give you a bin width that's not a nice even number, and for simplicity's sake, it's just easier to have a bin width that goes by 5s or 10s or 15s or whatever it may be, or 2s depending on the data set. So just keep that in mind if you create a histogram on your calculator. Now it wants us to describe the distribution. We've talked about distributions and describing them before. We use the SOX acronym: shape, outlier, center, and spread or variability. So I want you to take a moment to pause the video and think about how you would describe this data using the acronym of SOX, and then press play when you are ready to see the answer. All right, so hopefully you've done this on your own because, well, with stats, you really need to make sure that you're practicing on your own first before you see my answers. Also know that my answers are more textbooky type answers, so if you are feeling like you didn't write down exactly what I wrote down, that doesn't mean you did it wrong, you just did it differently, and that's okay. So let's go through what I have. So for shape, I said, the histogram is skewed right and unimodal. Most states have less than 10% residents born outside the U.S., but some have a higher percentage. Let's zoom out a touch. Unimodal because there's only one peak, and it's about skewed right. And then I just gave a little bit more information in terms of context with the percentages because I could. If you don't have the second sentence here, that's fine. I mostly added it in because it was a really good, easy place to add in some context. If you left it out but still have context later on in the description, then that's totally okay. Outliers, I said none because it doesn't appear to have any here. Outliers are some really extreme values, and we're eventually going to get into calculating those mathematically. Center, I said the midpoint, which again is the center of your data, the middle of your data, is approximately between 5 and 10% of residents born outside the U.S. I can't give an exact number because we have bins here, and even my table doesn't give me the ability to find that exact value. So I need to kind of use this gray area language of approximately between, and then the bin that I find it approximately between. The spread of the variability, I said the percent of residents born outside the U.S. Varies from 0% to 30%. So I just gave the range here. I really can't do much more than that because the downside of histograms is they don't give us very specific information. We can get a good general idea of what's happening within the data, but we don't know specific data points and data values, and so we can't give much more information than that. The very last thing we're going to talk about in 1.2 is compared to the stem and leaf plot, what details does the histogram lack? I've already kind of talked about this, it lacks detail. Oops. I can't see specific data values because they're all grouped together in this bin. In that example of the histogram, I don't know how many of these 20 states are closer to the 0% or closer to the 5% range. I just don't have that information. It's lacking that detailed piece. Whereas in a stem plot, I do have all that information. It says, when would it be beneficial to use a histogram rather than a stem and leaf plot? Well, stem and leaf plots use all the specific data values. Graphing 50 dots or 50 values on a stem plot can be time consuming. Think if we had 100 or 1,000 pieces of information. A histogram is a little bit more concise and can be easier to collect or visualize large groups of data. Where you can find to create a histogram on the calculator is here. It's on page 36 of the textbook. I strongly recommend that you figure out how to do that. It's going to save you a lot of time on the AP exam. You should not be creating histograms by hand, especially if it's a multiple choice problem. It's going to be way easier to create it on your calculator and quickly pick which histogram is the correct one. And then it says create a histogram on your calculator. Feel free to write any notes below. So this is just for you to kind of give yourself, so you don't have to keep turning back to the textbook, give yourself some quick notes here on how to do it on the calculator so you can just refer back to the notes packet versus the really big textbook. All right, that's all of 1.2.